Hello everyone, welcome to the second session of this blockchain and its applications course. So in the last session, we talked about the concept of decentralization and how it is interesting and what type of problems occurs in a decentralized network. Okay, so we have seen that in a decentralized architecture, there are multiple different stakeholders are there who actually do not trust each other and they want to coordinate with each other. Okay, so in this particular lecture, in this particular session, we will look into the blockchain properties and basic cryptographic primitives. So the concept of discussion, okay, here the concept of discussion is in today's session will be decentralization with a blockchain, the properties of blockchain, definition of blockchain, and cryptographic concept functions. Okay, so that we will see in when we discussed about the decentralized when we discussed in the last session about the decentralization model and by taking an example on medicine industry. Okay, so how we can effectively design or implement decentralized solution to solve the problems that was arised in for creating a decentralized model. Okay, so that we will discuss and we will then we also will be make a solution the problems that arise on creating a decentralization with the blockchain problem. Okay, so the requirements for a successful supply chain. Okay, so in the requirements for a successful supply chain that we are talking about, that the stakeholders or the players, suppose just like that we described in the session, first session about ups, downstream, and the middle persons, okay, the retailers. So they needs a strong coordination among these players. Okay, the players who actually associated with this supply chain, okay, they needs a strong coordination. This is the primary actually this is the primary requirement of this successful supply chain. Okay, so individual players, as I have mentioned earlier, that they do not trust each other, but if we can develop a solution, okay, through which they can actually coordinate with each other, okay, and each others, and then and of course that particular solution possibly gives a kind of better view, okay, kind of better view about the entire platform, okay, entire business model of them for themselves actually. So let's see how we can design a decentralized solution for the problems which we have seen in the case of medicine supply chain in specific model. Okay, so in such cases, okay, so assume that I have a, so moving towards a decentralization model, okay, how we can create and how we can solve those problems that arise in the for creating a decentralized model. Okay, so assume that I have a blackboard. Okay, so I have a blackboard and it is something that everyone can get access that blackboard, but at the same time, okay, whatever they are writing on that blackboard, okay, that becomes permanent. That means the players or the stakeholders that actually associate with this decentralized network, okay, then they have to, if they have to write something, okay, that for some, if they want to uh, note something for, or if they want to write something as a record, okay, they have that access and they can write on that blackboard. Okay, so whenever they will write something on that blackboard, that becomes permanent. Okay, no one can actually change that record. Okay, so everything on this blackboard will be recorded and will be recorded as permanently. So so now we have to think about the properties of this blackboard. Okay, so this blackboard has a infinite space and no need to erase anything. So and also you can use this blackboard as a infinite space, but you don't have that authorization. You can't delete any record. Okay, if you if you write that data or record by mistake, you can write, no issue is there, but you cannot erase it from this blackboard. Okay, it will be stored as a permanent. So means it means that every whatever the information, okay, you will write will be there. Okay, so every historical information, okay, will be stored here. That means suppose today you are writing something on this board. So as no one has the authorization to delete or erase anything from this blackboard. So in that case, we can assume that this blackboard will store all the historical information that were recorded prior. Okay, so by 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 looking those historical informations, okay, so anyone can verify that what has happened, okay, or whether certain discrepancies that have been observed or not. Okay, so by looking or by measuring those historical information, we can easily get the informations about that whoever written this record, and if is that record has been written is a in a by mistake or intentionally, or we can also can find out the discrepancies, okay, of any record. So by applying blockchain, actually by applying the blockchain technology, we can find that this is we can find out that by applying the blockchain technology, we can find out the historical information, and also if there are any discrepancies are recorded, we can find out everything. So this is the first property of this blackboard actually. Okay, this is the first property we can assign of this blackboard. So the second thing of second property of this blackboard is that everyone can see all the logs and verify. Okay, this is the second property of this blackboard, is that everyone can see all the logs, okay, whatever it is recorded, and verify it. That means whatever informations, okay, whatever information is made public, okay, there are okay, whatever information is made public, these are kind of, this will be the you can say that the all the records, all the informations will be in a transparent information. Every information will be transparent information, and anyone can able to verify the information. Okay, anyone can verify that information by looking at this blackboard. Okay, so the third property, okay, that we will talk about of this blackboard is any change in information, okay, any change in information is visible to everyone. That means what? That if you have written something, okay, by mistake, that I was talking about, that suppose you have written something by mistake, and it may happen, it may happen always, as if we assume that we all are human beings actually recording, who are taking those records on this blackboard. If we assume that we are human being, then it may happen that we can write something by mistake. Okay, it may happen. So then if you written something by mistake, okay, then if you want to change it, if you want to change that information, then you are not allowed to do it, okay, to erase it actually. So what we can do, okay, we can specify that this has been written. We can specify that without, as you don't have the authorization to erase the information which you have written by mistake, okay, but you can specify on the blackboard that this has been written by mistake, and everyone, you can also specify it like this, that by written that this information is written by mistake, and okay, and everyone, and this data or this record will also be visible to everyone. Okay, that means everyone can look into, or can visit, can it is visible to everyone. Everyone can look at it. Okay. So the next property of this blackboard is the board is not erasable. No one can deny that latter. Okay. So that means that this board is not erasable. So if something is written once, okay, in this board, and no one can erase it further. Okay. So that means it will be stored as a permanent basis. No one can deny that. Okay, the person who has written that information by mistake can specify on that blackboard that this has been written in a by mistake, but he cannot deny that letter. Okay. Now the question is, so we have seen the properties of this blackboard. Now the question is, who will maintain this bulletin board, or who will maintain this bulletin board? Okay. So in the end-to supply chain management, okay, there is no centralized coordinator actually, because as we are talking about the decentralized data structure, that means every you can say that every um, players or every stakeholders, they have their own input, they have their own criteria. Okay, that means they have their own thinking points to how they will increase, or how they will profit more from the market. Okay, so as they are working on a decentralized model, so as it is not a centralized, as there is no centralized coordinator. Okay, so who is actually coordinating the entire process? So actually, decentralization always improves the security. Okay, if we say that we will, that case, that if there is a central coordinator, then we that means a dictator is there, and everything is depend on that person. Okay, but in decentralized model, everyone is free and everyone has their own input. So now, if we say that who will maintain this bulletin board, then someone, we can say that we will buy cloud from Amazon. Okay, we can say that to maintain that bulletin board, we can buy cloud, or we can also upload our server, or whatever it is from Amazon. We can take it. Okay, but then the next thing that comes out, who will manage it and provide? Who will manage it and who will provide the cost? Okay, now, these are the questions that comes when you will say that if you want to buy cloud from Amazon, then the next question that comes out, who will manage it? Okay, and who will provide the cost? These are the questions that can arise. So in such cases, okay, uh, you can say that one of the enterprises maintain a private cloud. Okay, and what is the guarantee that it is not fraud? Okay, you can say that if you buy a cloud, if you buy cloud from Amazon, okay, then how can you be sure that there will be no fraudulent activities? How you can be sure, or what is the guarantee of that there will be no fraudulent activity can happen? Okay, so now that now that who will maintain this bulletin board? Okay, so let everyone maintain the same copy of the board individually and independently. That we can say that let everyone maintain the same copy of the board individually and independently. That means that whatever the data or the information is recorded, whatever the data or the information is recorded on this bulletin board or the blackboard. Okay, everyone will get the same copy of the record. Okay, of that board record individually and independently. Okay, so it means that rather than having a single copy, okay, rather than having a single copy of the board that is maintained by someone, okay, that is maintained by someone, I am making a decentralized architecture, okay, I'm making actually a decentralized architecture of that board. That means here you can say that no one is the sole owner of the data. Okay, that means that no one is the sole owner of the data. As it is a decentralized network, then every whatever the update will be there on the bulletin board, okay, everyone will get a individual copy or independent copy of that updation. Okay, so we can say that in a decentralized network, that no one is the sole owner. Okay, no one is the sole owner of the data, but everyone has a copy of the data. There is no as there is no central database. Okay, if there is a central database, if it would be a central database, then every data will be stored on the central database, and that database will actually monitor the whole network system. Okay, but as it is a decentralized network, so no one is the sole owner of the data, but everyone has a copy of the data individually. So in that way we can easily set up, okay, so in that way we can easily set up a decentralized network. Okay, so as we said that no one is the sole owner of the data, and but everyone has a copy of the data. So, and as there is no central database, and that is why we are moving towards making a decentralized network or decentralized marketplace. Okay, so as everyone holds exactly the same copy of the data at the same instance of the time. Okay, as everyone is holding the exactly the same copy, because when the updation is happening on that board, okay, every updated data, okay, will be sent to the every stakeholders or the every players that are actually exist on this decentralized network will be sent separately. Okay, individually and independently will be sent every copy. So as everyone holds the same copy of the data at the same instance of the time, okay, well, this is the kind of specific requirement, okay, that we want on this decentralized marketplace. So this is called a kind of what we say as the distributed consensus problem. Okay, this is called as the distributed consensus problem, that everyone holds exactly the same copy of the data at the same instance of the time. Then we can say that there here actually some kind of distributed consensus problem actually arise. Okay. So we can, so as there here a distributed consensus problem arise, and we will elaborately describe about this distributed consensus problem in our later session. Okay, so now we can say that we can replace this blackboard with a particular data structure that is called the blockchain. Okay, so as there is some problems are arising, just like the distributed consensus problem are arising, so we can replace this blackboard, okay, with a certain data structure or the particular data structure that is called the blockchain. Okay, so now the question is, what is a blockchain? Okay, now the question can arise that what is a blockchain? Okay, so blockchain is an immutable, append-only, okay, ever-growing chain of data. Okay, so data once added cannot be deleted or modified. So that is the data structure. That is the blockchain data structure actually. That once an immutable data structure is blockchain. So immutable data structure means, so immutable data structure, immutable, append only, ever growing chain of data. Okay, so data once added cannot be deleted or modified. That is called the append only. Okay, so append only means you can only add data, whatever the information is. It may be the correct data, it may be the false data. Okay, whatever the information is, but you can append only. Once the data is recorded on that blackboard or on that data structure, you cannot delete. You don't have any authorization to delete or modify that data. Okay, and also as I talking about that, an immutable. So immutable means that no one can change it. Okay, that is called the immutable. So no modification can be done. Okay, and it is also ever growing chain of data. That means as it is a append only, so ever growing. So informations or records are actually added one by one, and blocks are created. One information, when one single information is added on that data structure, that means a block of data is created. Okay, that means a chain is created one by one, the ever growing chain of data. That is why it is called that append only. So so new information actually is added. Okay, new information is added to the chain in the form of new blocks. That means when someone is adding their payment information or any other information, okay, it is added to that chain, that blocks of chain, and that information is recorded within a particular blocks. Okay, that information is recorded within a particular blocks, and that then those blocks are actually connected with a chain. That is why it is called as blockchain, because whatever the information is recorded on that blocks, or whatever the information recorded on that network or on that data structure, okay, and those information are stored in a blocks, certain blocks. Okay, so and those blocks are actually connected with other blocks, and this how a chain is created. Okay, that is called the blockchain. Okay, and this is the structure that each blocks is actually connected with each other with certain chain. That is the blockchain. Okay, so we can say that means that I am forming a blockchain is a decentralized, immutable, append-only public ledger. Okay, a decentralized, immutable, append-only public ledger. So this is the properties of blockchain. You can say that it is a decentralized architecture. Okay, so this is the blockchain, actually decentralized architecture. Blockchain is a decentralized architecture. Blockchain is a immutable data structure. Okay, blockchain is a append-only data structure. Okay, blockchain is it is also a public ledger. Okay, so as it is you can say that decentralized network. Okay, decentralized network means, as we can say, blockchain uh, technology is based on decentralized network or decentralized architecture. Why? Because no one has no one is the sole owner of any data. Okay, no one is the sole owner of data. Everyone will get the each copy of data individually and independently. Okay, so there is no central database. Okay, there is no central or main dictator. So that is why every data will be sent to the individual persons individually and independently. Okay, that is why it is called as the decentralized network. Okay, and every and also in this individual network, everyone, the players or the stakeholders who are associated with in this network has their own profit, has their own input to increase their profit margin also. Okay, and the next property of blockchain is the immutable. Okay, so immutable means that once the data is recorded on that block, okay, no one has the authorization to change or modify that data. That means it is unchangeable. Okay, that is why it is called as immutable database. Okay, and also another property of blockchain is that append only. That means we can only add data. Okay, we can only add data on this blockchain property. That means we can only the blocks will be added. Okay, on this blockchain network or blockchain architecture. That is why it is called an append only. So no one can delete once the data is recorded. Once the block is created, okay, no one can delete that blocks. It is only it is that is why it is called as ever growing chain of data, as it is a append only data structure. And also it is a public ledger. Okay, public ledger means it is a public ledger because everyone is actually is going to maintain their own copy of the blockchain. Okay, and whatever the information they want to log, actually they want to log in the blockchain. Okay, they do it publicly, so everyone can see it. That means we can say that whatever the information they are actually recording or actually logging logging on that blockchain architecture. Okay, so every data is actually transparent. Okay, every data is actually transparent. No one can change that data, or no one, and everyone can see every information. Okay, as it is a transparent informations are stored in these blocks. Okay, so these are the properties of blockchain actually that we have actually discussed on this session. Okay, so I think you all have understood it, that these are the blockchain properties. That decentralized, it is a decentralized architecture. It is a, immutable based data structure. It is a append only data structure, and it is also a public ledger. That means whoever will add data, or whoever will add information on this data structure, every information will be transparent. That means everyone can see whatever the information will be loaded on that architecture or the blockchain network. Okay, so the next thing that we discuss here, that basic cryptographic primitives and hash functions, because we have seen that in blockchain architecture or blockchain technology, cryptography is actually hugely or enormously used, because the blockchain technology is based on this cryptographic structure or cryptographic knowledge. Okay, the whole blockchain technology is based on this cryptographic knowledge. Okay, or cryptographic primitives, you can say. And they are in the cryptographic primitives, we use actually hash functions. And in this, in the blockchain, actually we actually here is actually 256 bits of hash function, just like SHA-256 are enormously used in blockchain technology. So we'll discuss about here. We'll discuss about the basic cryptographic primitives. So behind the blockchain technology, and on that basic cryptographic primitives, we'll discuss about the digital signature hash functions. Okay, digital signatures that are used hash functions, and in that hash functions, we'll use that this hash function used to connect the blocks in a chain in a tamper-proof way. Okay, that means these hash functions are designed in such a way that when the blocks are created, blocks are actually connected in a block in a chain. Okay, and these blocks are actually usually used to this hash function actually used to connect the blocks in a chain in a tamper-proof way. That means that suppose one block is created, and this second block is associated with the first block in a through a chain. So this hash function actually, the second hash function actually store the hash value of the first blocks. Okay, that is connected with a chain. That means if someone want to hack the second block, someone want to hack the first block. Okay, so someone want to if someone want to hack the second block. Okay, second blocks, that means if someone wants to hack the information that's stored in the second block, then he has to hack the first block also, because the hash value of the second block is actually stored on the first block. Okay, so that is why this hash function actually used to connect the blocks in a chain in a tamper proof way. And by using these hash functions, actually this blockchain actually blockchain technology is be free from the tampering or data tampering or parameter tampering vulnerability. You can say that it is a tamper proof, it is actually tamper proof technology or tamper proof network you are creating by using these hash functions. And there is also the digital signatures that are used in blockchain, is that digitally sign the data. Okay, so can deny about their activities. If we take whatever information is recorded on each block. Okay, and if whoever actually actually storing that information on that block. Okay, so if he that person has a digital sign on that document, then he cannot deny about his activities. Okay, so and also other can check that whether it is authentic or not. Suppose you are actually doing some information doing some transactions, and if you're if on the and that will be stored in the as informations of block. And if you're if there if there is a signature is available for you, then when in the next in the latter part, when you will look into the transaction or look into the okay, you can also cannot deny also about that you have not performed it, that someone has done it or in case of on the case of you. Okay, you cannot deny that, okay, as there is a digital signature of you is there. So as cryptographic hash function, so in the cryptographic hash function, okay, in case of cryptographic hash function, takes an arbitrarily sized string as input. Okay, so that means that in cryptographic hash function, it first takes an arbitrarily sized string as input, such as you can say that input m. Input m is the arbitrarily sized string that has been taken as input, and that is this input m is called as the message. Okay, and there is a fixed size output actually, and that output is of course will be the 256 bits are used in black as in actually in blockchain. We actually use the 256 bits of hash functions. Okay, then this is actually used in the blockchain technology, so that if there is a string, there is a input m that is called that as the message. Okay, there must be a fixed size output, and that output is called as output h of m, and that is called as message digest. Okay, that is called as message digest. And also there is a all these are the efficiently computable also. And this input m, whatever the arbitrarily or random input you are taking, and you are taking and you are storing on that blocks. Okay, that the message that you are specifying it as the message. And also the fixed size, that fixed size output, actually 256 bits are used in blockchain, and that is called the message digest. Okay, efficiently computable. And the cryptographic hash function properties that we are talking about, there are some properties of this cryptographic hash function that is called the deterministic, collision free, hiding, and the puzzle friendly. Okay, so this deterministic means that the given a hash function and given a particular message that is called the m, that is called the message, and it will always generate the same message digest. That means if you had the message that like m is the input message, there will be a output message or message digest will be h of m. Okay, so that will be the identical hash value for identical input data. And then the second property of this cryptographic hash function is collision free. So if two messages are different, that means the m1 and m2, that this is the two different message. Then if you take input of two different messages, the message digest or output message will also differ. That means for m1 the output message or message digest is h of m1, and for m2 the message digest will be h of m2. So this h of